Okay, hi everyone, and welcome back to this video series for Introduction to Firewalls, forwarding DNS packets to an ISP. Some firewall administrators find that allowing an internal DNS server to communicate with any DNS server on the internet is a security risk and are unwilling to allow DNS connections to any DNS server on the internet. In this scenario, as shown in figure 7.3, DNS traffic is registered to a single internet-based DNS server. Configure the internal DNS server to forward DNS requests to a specific DNS server if the internal DNS server can't resolve FQDNs. After your internal DNS server forwards the DNS requests to the ISP's DNS server, you have no control over how the DNS query is resolved. Sorry, now that's too big. Okay. The ISP may use route hints, or it may forward the DNS request to another DNS server on the internet. The point is, you really don't care for your firewall. All you have to do is configure firewall rules that allow your DNS server to forward DNS requests to the ISP's DNS server. Based on figure 7.3, the firewall rules in table 7.5 must be established at the firewall to allow the internal DNS server located at the IP address 172.16.1.206 to forward DNS queries to the ISP's DNS server located at the IP address 39.200.14.56. So table 7.5 firewall rules for DNS access using a forwarder. DNS TCP 172.16.1.206 ANI 39.200.14.56.53 allow. DNS UDP 172.16.1.206 ANI 39.200.14.56 14.56, 53 and allow. File transfer protocol, FTP. Another common use of the internet involves downloading files such as drivers and applications from the internet. Typically, the file transfer protocol, TFTP, is used to download files from the internet. FTP provides the ability for either anonymous or authenticated users to access a designated FTP server for the purpose of downloading or uploading files. Just because an application supports authentication doesn't mean that the authentication is secure. FTP does support authentication, but it uses clear text authentication. This means that a packet sniffer can read the packets and determine the password that was used. Packet sniffers are either software programs or hardware devices that are able to inspect the actual content of packets transmitted on the network. Any protocols that transmit data without encryption can result in the packet sniffer capturing confidential data such as passwords. Ensure that internal network users are informed of this vulnerability and recommend that they never use their network password for accessing resources on the internet. FTP uses two separate connections between the FTP client and the FTP server to support transfer of data as shown in figure 7.4. The control channel is used to send all commands between the FTP client and the FTP server. These commands include FTP get and FTP put commands for the transfer of data. In response to an FTP put or FTP get command, a separate channel is established to transfer the data between the client and the server, with the FTP server initiating the connection. In addition to the two channels, your firewall configuration may also have to support the use of passive FTP clients. Passive FTP client negotiates with the FTP server to determine what port is used for the data connection, rather than the FTP server initiating the data connection from TCP port 20. After the data port is negotiated between the client and the server, the client will then establish the data connection to the FTP server, connecting from the port above TCP port 1023, and the client to the chosen port at the FTP server. Some people, including US authors, consider the use of passive FTP clients to be a security hazard because a firewall rule must be established that allow external clients to connect to any port on the FTP server. Unless your firewall implements an FTP application proxy which is able to analyze the commands issued by the FTP data session in order to ensure that the FTP session is taking place as required, don't allow passive FTP clients to connect to your FTP server. Table 7.6 shows the firewall rules that must be established at the firewall in order to allow internet-based clients to connect to an internally located FTP server. This set of firewall rules allow any host on the internet to connect to the FTP server located at the IP address 172.16.1.201. So table 7.6, firewall rules to access an internal FTP server, FTP, TCP, ANI, 172.16.1.201, 21 allow. FTP data, TCP, 172.16.1.201, 20, ANI allow. FTP, PASV, so it's probably passive. TCP, ANI 172.16.1.201, ANI allow. FTP TCP 172.16.1.0/24 ANI 21 allow. FTP data TCP ANI 2172.16.1.0/24 ANI allow. Messaging and conferencing. Many people have fallen in love with instant messaging. Instant messaging is for the type A personality. It enables you to determine if someone is connected to the internet and get him or her to respond immediately to a question instantly. As you may have guessed, we're big believers in instant messaging. This section describes the firewall rules that are required to use the available instant messaging, chatting and conferencing software that is available today. Specifically, this section takes a look at the firewall rules necessary to use America Online AOL messaging, Microsoft Network MSN Messenger and Windows Messenger, and Microsoft NetMeeting. America Online AOL messaging. America Online was one of the first instant messaging services on the internet. With AOL messaging, you can determine whether friends are online and chat with them using the AOL messaging software. If you want to use AOL messaging, your firewall must be configured with the firewall rule as shown in table 7.8. AOL TCP ANI 5190 allow MSN Messenger and Windows Messenger. Microsoft Network MSN Messenger and Windows Messenger allows messages to be sent immediately to online contacts in your address list for authentication. Both versions of Messenger use passport authentication. Passport authentication is also used for other Microsoft services. Table 7.9 shows the firewall rules required to allow MSN and Windows Messenger clients to send instant messaging to other MSN and Windows Messenger clients on the internet. So firewall rules to allow MSN Messenger, Windows Messenger, IM, TCP, ANI 1863 allow. HTTP, TCP, ANI 80 allow. In addition to instant messages, MSN Messenger and Windows Messenger also enable users to transfer files and transmit voice calls between two computers on the internet. Because dynamic ports are used for this purpose, the firewall must implement a gateway or application service that enables the files and voice transmissions to be rerouted to the correct client behind the firewall. Table 710 shows the ports that are used by the MSN Messenger and Windows Messenger for file transfers. So here you have MSN and Windows Messenger file transfer firewall rules. File transfer incoming any recipient 68916900 allow. File transfer 172.16.1.0/24 any recipient IP 68916900 allow. Voice communication between MSN and Windows Messenger clients is even more complex to configure. Voice communications require that several ports be open at the firewall to allow the voice connection to take place. If your firewall implements NAT, the use of static ports for the voice transmission limits voice transmission to a single host behind the firewall at the time. The firewall can only have a single instance at a time using UDP port 6901. The ports used by MSN and Windows Messenger are shown in table 711. So session establishment, any TCP port 6901, voice transmission UDP 6901, UDP port 6901, voice conversation establishment termination TCP port 22004700, TCP 22004700. NetMeeting. Microsoft offers an alternative to instant messaging that allows for online collaboration. Microsoft NetMeeting allows application sharing, whiteboard sharing, and video voice conferencing to take place over a network. Microsoft NetMeeting uses two separate technologies to allow collaboration over network links. T120. The T120 standard allows multi-point data conferencing. This feature allows multiple users to take an application sharing scenario, such as multiple users editing a single document. H323. The H323 standard allows for video and voice conferencing over unreliable switched networks such as the internet. NetMeeting session is established by initially connecting to the internet locator server ILS that listens on TCP port 389. After you have established a connection with the ILS server, you can then start a NetMeeting session with any other users that are connected to the same ILS server. Alternatively, you can connect directly to the IP address of the computer on which the person whom you want to communicate with is sitting, or you can implement an H323 gatekeeper which routes calls to multiple people in an organization, just like a telephone switchboard routes voice calls from a central office phone number. ILS is not the only service that uses TCP port 389. Port 389 is actually reserved for use by the Lightweight Directory Access Protocol LDAP. Although similar in function, ILS is not an LDAP service. Table 712 shows the ports used by NetMeeting and must be opened at the firewall to allow NetMeeting client to participate in NetMeetings. So table 712, Microsoft NetMeeting firewall rules. Internet locator service, any TCP 389. User location server, any TCP 522. T.120 protocol, any TCP port 1503. H323 call setup, any TCP 1720. Audio call control, any TCP 1731. H323 call control, any TCP port 1025 65536. H323 streaming, any UDP 1025-655-36. So I'm going to leave it here to see even for this video. If you like listening, please consider like, sharing and subscribing. Thank you very much.